Good morning, ladies and gentlemen. Let's see if we can keep this one under 20 minutes, yeah? Solving equations today, that means we're going to be doing a little bit more math. The key, one-to-one property. What this means is, if you have b to the x equals b to the y, then x must equal y. We've applied this property sometimes when using the log rule, but today we're talking about it. This is the important thing. It's all about creating the same base. All about that base, about that base, about that base. That's a hit song. You should listen to it. All right, so here, example 1, we know that we can't do anything because they don't have the same base yet. The key, though, is looking at one of our bases that currently is there and thinking, can I make that the same base as the little one? It's hard, probably impossible, to make this 6 into a 36. Not impossible, but hard. But we could take this 36 and say, well, I know that 36 is equal to 6 squared, which means I can rewrite this as 6 squared, and then you would multiply these exponents here. So the x plus 1 stays, and then whatever new exponent you create multiplies by it, equals 6 to the x plus 6. And now we have the one-to-one property. They have the same base, which means these bases don't even matter, and now we have this easy Algebra 1 equation. Distribute 2x plus 2 equals x plus 6. I'm going to subtract x on both sides, giving me x equals, subtract 2 on both sides, 4. Bada bing, except you have to check for extraneous solutions. Check for extraneous. Alright, so plug in here, 36, 4 plus 1 is 5, and I'm plugging that right up here, equals 6. 4 plus 6 is 10. Check to make sure that's true using your calculators. On. 2 plus 7, 1, 2. 36 to the 5th power is that big number. 6 to the 10th power is that same big number. Check, check. Works to go. Alright, here, fractions. What do we say about fractions? Negative exponents. If I need 64 to be the same as 1/2, then I know I need a negative exponent. Alright? So here's what we're going to do. We're going to take our 64. The base here is like 2. How many times does 2 multiply to be 64? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 6 times, okay? 6. So 64 equals 2 to the 6th, right? But I want it to be a fraction, so if I make it 1 over 2 to the negative 6. Feel me, dogs? So this becomes 1 over 2 to the negative 6 times the current exponent of that 64. So all I did was change 64 to this, and then this current exponent has to multiply by your new exponent. And now because we have the same bases, the 1/2 bases go away. C equals negative 6 times 1/2, negative 3. Let's check to see if that's right. When I plug in 1/2 to the negative 3, I get 8. Wow, that's neat. And because that's the only variable piece right there, that's the only place I have to plug it in, as long as 64 to the 1/2 gives me 8. Swag. You could also do it turning that into a square root and then changing some things there, but I like this method better. So there you go. Alright, that's exponent properties. Using logs, if we're given a log, we know that x to the log base x of anything, y we'll say, the x and the log go away, which that means this whole thing just equals y. So if I say, well, I've got log base 2 of x equals 3, if that was raised to a 2, then I raise this side to a 2, and that piece goes away, leaving me with x equals 2 to the third. Cool? So if I have a log or a natural log, because I know I could put an e there for natural log, you raise it to whatever the base of the log is, and then those pieces kind of go away. So the first key is isolate the natural log or the log or the exponent piece or the natural e piece first. Okay? So like this example, I don't have natural log by itself. I have 2 times the natural log. Divide both sides by 2. Natural log of x equals 9. If I raise that to the e and raise that to the e to the natural log of x is just x equals e to the 9th, which we don't know what it is. Plug it in your calculator. There will be a calculator section on your test. The E button is this little blue button right here above ln. So notice there's our natural log and log stuff. So second ln e to the 9th, 8,103. Or you could leave it as e to the 9th. It just depends. Read the directions. It'll say round to the nearest tenth, or it'll say leave as e to the 9th. Either way. Alright, just a few more steps on this one. Minus 7, negative 3, log base 10, that's right, of 10x equals 13 minus 7, obviously it's 6, divide by negative 3, divide by negative 3, we get log base 10 of 10x equals negative 2. So I'm going to raise this to the power of that 10, raise negative 2 to the power of 10. That piece goes away. X equals 10 to the negative 2. So after that step, you're pretty much done except for simplifying. That becomes 1 over 10 squared, which is 1/100th. No calculator necessary. Some of these you're going to get a calculator on, some of them you're not. Alright, log base 10 of x to the 4th, pop a 10 under there, pop a 10 under there, x to the 4th equals 10 to the 2/20th. Oh, just kidding. Only one mistake so far, if you're keeping count. Isolating logs means we can apply the exponent property from last class. This 4 can jump down in front. That's the equivalent expression. Divide by 4 to get rid of it. Log base 10 of x equals 5. Raise that to the 10, raise that to the 10, goes away. X equals 10 to the 5th, or, if you're really good, 100,000. 5 zeros. 1, 2, 3, 4, 5. Alright, last one here. Divide by negative 3. Divide by negative 3. Natural log of x equals 8. Raised to the e power. These e ones are probably the ones we're going to need the calculator the most on, because we don't know what e is. E to the 8. Cool, cool, cool. Don't forget to plug back in to check these things. So for example, negative 3 times the natural log of e to the 8th power, negative 24. Check. Alright, the one-to-one property applies for logs as well. If you have log base b of x equal to log base b of y, then x must equal y. Alright? So that's very, very nice. This part should probably be written right there. I'm sure it got fixed on your notes. The key here is when I don't have one log on each side, you need to condense first, which is why we learned condensing last class. So I'll do that in that one. But here, log base 3 of x squared plus 3 equals log base 3 of 52. We're good to go. The reason why we can do this is if I raise this to the third and that to the third, those pieces just go away. X squared plus 3 equals 52. Yeah? Because it's a single x squared equation, we can just solve by using square roots. So x squared equals 52 minus 3 is 49. Nice. Square root. X equals, don't forget your plus or minus, 7. Now, plug them back in. Let's do this right side first because that's going to come out to be a number. And to get a log base, you're going to push mode. Just kidding, you're going to push second catalog and scroll all the way down to L. So how's your day going? Oh, pretty good? Mine too. Blah, 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 blah. It's all about the base, about the base, about the base. We're almost there. There's G. Anybody going to ACL? Oh, you're probably at ACL right now while I make this thing. LMNOP. Nope, not there yet. Here we go. L log. Log base. I bet you that's on here somewhere. Anyway, boom. Log base 3 of 52 needs to be 3.59. All right, so we're going to hit second answer. Nope, just kidding. Second enter, and it brings it the same thing. So log base 3 of, this time, 7 squared plus 3. Same thing. Second enter. Parentheses, negative 7 squared plus 3. Same thing. They both work. Check, check. From now on, I'm just going to assume, I'm going to say plug it in your calculator to make sure it works, and then we're going to move on. All right. This is the problem right here. We've got 2 logs on this side. This one's good to go. Log base 4 of x. Put them together using our condensing properties. When you're adding, you're multiplying. Log base 4 of 3 times x minus 2. And again, when you raise both sides to 4, the log base 4 goes away. I'm just going to do that from now on. X equals 3x minus 2. Distribute 3x minus 6. Subtract negative 2x equals negative 6. Divide x equals 3. Plug it in. It works. Excellent. Example 4. We've got exponential equations. So in this case, instead of raising to the exponent, we're going to do the natural log on both sides. Natural log of 3x equals natural log of 7. We can take the natural log of both sides. Using our properties over here, we can move the x down here. Yeah? Isn't that neat? X natural log of 3 equals natural log of 7. How do I get x by itself? Divide by the natural log of 3. Divide by the natural log of 3. X equals whatever that jazz is in your calculator. ln of 7 divided by ln of 3. 1.77. Sounds great. This will be in the calculator section of your test. Okay? Round to the nearest hundredth. That's 1, 2 spaces. All right? E to the 2x equals 8. Let's take the natural log on this side, see what happens. Natural log of e, 2x plus 1 equals natural log of 8. What happens when you take the natural log of e? It goes away, leaving you with 2x plus 1 equals the natural log of 8. Subtract 1, subtract 1. 2x equals natural log of 8 minus 1. Divide by 2. Do all that in your calculator. I highly recommend you follow these steps and then round. So x equals, watch this. Watch how I do this. Natural log of 8 minus 1, enter. Divide by 2, enter. 0.540. When I round that here, that becomes a 0. That rounds that, 540. Cool? All right. Don't forget tutorials are available. Condense. And when you add, you multiply. Same base goes away. Distribute. X squared minus 3x equals 28. Oh, you know this is going to be fun. X squared minus 3x, pull minus 28. Whew. Equals 0. We're about to factor, y'all. The two numbers that multiply to give me negative 28 and add to give me negative 3 are negative 7 and positive 4. Because the a value is 1, I know these are going to be my roots. Jumps to here. So x has to equal 7 or x has to equal negative 4. If you are not good at this, you get your booties in tutorials. But double check this, ladies and gentlemen. Double check and you will find that negative 4 does not work. Because negative 4 minus 3 is a negative. And you can't take the log of a negative because there's no exponent for 10 that would give you a negative value. So it doesn't mean that negative solutions are extraneous. It just means that this one is, because when you plug it in, it will stay a negative value under the log or in the log. So you can't have that. All right. Over here, definitely need to condense. Natural log of x plus 2 times 3x minus 2 is equal to 2 natural log. Except in this case, we need to have the same base and the same log. So I'm going to take this 2 and put it right there. And make sure to put that in parentheses. Boom. Okay? So that 2 came from there. Now our logs go away. FOIL 3x squared minus 2x plus 6x, which makes plus 4x minus 4 equals 2x squared is 4x squared. Woo! We're moving everything to the right to make this positive. So minus 3x squared gives me x squared minus 4x plus 4 equals 0. Factoring gives us x minus 2 equals 0. So therefore, x must equal positive 2. Only one solution. When you plug it in, you will get the right answer. Checkity check. All right. Solve each equation and check for extraneous solutions. You should always be checking for extraneous solutions. So here we go. Same thing. So this becomes, I'm going to go right here. Log base 12 of 12x times x minus 1 equals 2. Because I only have one log, I'm going to raise this to the 12, raise that to the 12. Those go away. This one stays like 12 squared, which is 144. And 12 times x is 12x squared. 12 times negative 1 is negative 12x. Move your 144 over. 12x squared minus 12x equals minus 144. I just told you to move that over. Equals 0. Beautiful. Factor out of 12 to make this really easy. X squared minus x minus 12 equals 0. That thing doesn't matter anymore. Gives us x minus 4x plus 3. I know I'm going through this really quickly just because it's a long video. You should pause it and factor that yourselves. Which means x equals negative 4 and positive 4. X equals negative 3. When you plug in negative 3 right there, that is a log of a negative number. Can't happen. 4 does work though. Alright. It's going to be a little bit longer than 20 minutes. My apologies. This one is a good one to talk about because we'll be looking more at word problems next class, but we could figure this out. So the table shows the number of hits a new website received by the end of January and the end of April of the same year. If the number of hits is increasing is an exponential rate, this whole thing is exponential, identify the continuous rate of growth, then write an exponential equation. This is kind of like a review of what we did last class. I highly recommend making a new table with numbers. January is our first month. April is our January, February, March, April. Wait, January is 1, March is 2, April. There we go. April is our third month. January, February, March. Wait, January, February, March. Oh, nice. If you're looking at the copy of notes, there's a mistake in here, so watch out. That's going to make this really hard, which probably means I'm going to give up, but we'll see. I'm going to work through it, but that might make the video longer. January, February, March, April, 2, 3, 4. And if I start at 125 and get to 2,000, what rate would I be multiplying by? Let's see, 125 times 2 times 2 times 2? No, that's not going to work. Clear. 125. Here's what I'm doing, just so you can see. If you want to, you can just stop this video because your practice is just over that other stuff. If you want to watch, keep watching. 125 times 3 times 3 times 3? Nope, 2,000. Skip this one. Your homework is over solving equations. This is going to be our real world problems. We will address it next class for sure. Bye-bye now.